6.1, explore nonlinear relations. So, parabola. The definition of a parabola is a symmetrical U-shaped graph. Okay, and when we talk about U-shaped, we talk about like a happy face or a sad face. Okay, so the parabola is actually the shape. And a quadratic relation is an equation that describes a parabola. Okay, an equation in the form, okay, the expanded form is y equals ax squared plus bx plus c, okay, where it has to have this x squared term, so a cannot equal 0. Okay, a quadratic relation is one type of nonlinear relation. Okay, the graph of a quadratic relation is called a parabola. Okay, example 1. Graph the data in each table and then draw a line or curve of best fit through the points and then explain your choice. Okay, so we're going to graph 0, 1, 2, 5. Oh no, 1, 3, sorry. 2, 5, 3, 7, 4, 9, 5, 11, 6, 13, 7, 15, 8, 17. Okay, this looks like a line. Okay, it's not deviating, it's not going, like it's not curving at all. So I'm going to choose line of best fit. Okay, I'll put an arrow at that end too, because we're choosing the line. Okay, now 0, 16, 1, 9, 2, 4, 4, 0, oh, 3, 1, 4, 0, 5, 1, 6, 4, 7, 9, 8, 16. Okay, so this one is a curve because it's not going down by the same amount every single time. And we can see that it goes down and then up. Okay, you can't draw a line down and then up. So this is going to be a curve of best fit. Okay, I made this one a little bit smaller so I can fit the whole thing on one page. So example 2, the formula for the area of a triangle is A equals 1/2 B times H. Okay, where B represents the length of the base. Okay, so B is the base, and H represents the height. Okay, so in a right isosceles triangle, so right isosceles, what does that mean? That means we have a triangle and we have a right angle, and isosceles means that the two side lengths are the same. Okay, the length of the base equals the height. So if we think about this, base equals height. So why don't we go ahead and call both of these B? Okay, so instead of having area equals half the base times the height, we're going to simply have half the base times the base again. And what that's going to allow us to do is plug in the same number instead of plugging in like two different numbers type of idea for the base and height. We're going to just plug in the 1. We can also rewrite B times B as B squared, right? So area is going to be 1/2 1 squared, or 1/2 2 squared, or 1/2 3 squared. Okay, and we're going to go all the way down 1/2 4 squared, 1/2 5 squared, 1/2 6 squared. Okay, so the answers that we get are 1/2, 2, this is like 4.5. I'm going to put that as a decimal so we can go ahead and graph it after easily. 8, 12.5, and then 18. Okay, just put all of those into your calculators. You can write these out if you choose to. 1/2, 4 squared, 5 squared, 6 squared. Okay, and then what we're going to do is we're going to scroll down and we are actually going to graph this on our graph. So I just want to note that we're not going to graph the 0 because if we had a 0 length, there would be no triangle. So let's go ahead and just graph the points in here. 1, comma, a half, 2, 2, 3 and 4.5, 5 and 12.5, and then 6 and 18. And we're going to go ahead and connect those with a curve of best fit. Okay, and we can label A equals 1/2 base times height.